Hey everyone, it's Doppler 10 Meteorologist Ross Caruso. I have another fun experiment planned for us today. And again, we only need a couple items here. So we're going to need some ice cubes, a little prep work before, a couple different colors of food coloring. I have blue and red here. You can use whatever color you want. This will be good for the experiment we're doing today. And you're going to want to make some blue or red, whatever you want, colored ice cubes. So I had these in the freezer last night. So we have blue ice cubes. You can see I already have blue on my fingers from touching them. And then we also have a clear container, a rectangular container that's clear so you can see what's going on inside the tank. If you have one, that's perfect. A smaller rectangular one will do just fine. And you're going to want to put lukewarm water in here. So just turn on the faucet, fill it up about halfway. And what we're going to do is we're going to demonstrate what happens with a cold front and talk a little bit about a thunderstorm as well whenever we're watching the process that's taking place. But the first thing we want to do is we want to introduce some colder air. And this is going to represent a cold front. So we're going to take one of our ice cubes, and you can see it looks like some blue Gatorade there, and we're just going to drop it right in. And instantly you're going to see a lot of blue coloring that's going to go in. And now what we're going to do is we are going to add some other color into this, some red, and we're going to put a couple drops, and I'm going to give it a little bit of a stir. Not a whole lot, but I want these colors to really pop. So I'm going to just stir that up a little bit, like that. So you can see the difference there. All right. And now what we're going to do is just sit and wait and watch what happens. So what we're doing here is we're talking about cold fronts. And with cold fronts, what we see oftentimes is we see cooler conditions after the cold front comes through. That's usually accompanied by rain, thunderstorms, even severe weather. And in this particular experiment, we're talking about cooler air versus warm air. And this is a very important process that happens in every single thunderstorm, even when a cold front isn't even present. We have a clash of cool air running in with warm air. We get condensation, just like the cloud experiment we've showed you guys before. And we get condensation, which is a warming process. And that allows the clouds to continue to grow and maybe even grow up into a thunderstorm. What we're showing here is this cold front representing the ice and the blue coloring is much colder than the air or water surrounding it. And what that's doing is you can see clearly we have a layer of blue water near the surface, but some of that red water or the food coloring we put in, you can see how it's not near the surface. That's because this cold front is bringing in cooler air, which is causing the warmer air to lift. And we're actually getting a layer of blue, some mixture, and then predominantly red on top of that cold layer. So in this situation, we have a cold front that's coming through. It's forcing the warmer air to rise. The cooler air is more dense, thus it likes to sink. The warmer air in the environment is much warmer than the cooler air, so it continues to rise. And this is exactly how we get cloud structures to form, some towering cumulus clouds that could then grow up into cumulonimbus clouds where they reach heights of over 30,000 feet, and then you get downdrafts, which then brings rain and cooler air back near the surface, and there you have it, your very own cold front and a great explainer on how you can talk about different densities, cooler air and warmer air, and how thunderstorms form each and every day across the world. Hope you enjoy.